Okay, so last question of the paper. It's going to be difficult. That's their whole point with these things. I would take a second just reading this and taking it in, but essentially we've got a graph. They've even given us a sketch of the graph. We've got a turning point at 1 over e. That's all that we know about it so far. We know that it's a probability density function, so we know that between 0 and 1 of f of x is going to equal 1. We know that f of x must always be greater than or equal to 0, but this is kind of shown by this diagram. Alright, so let's have a look into the actual first part of the question. Show by differentiation that this is an antiderivative of this. Now, I personally do not think that they've given enough space to do the working out for this, for me, but let's find out whether it's possible. So, we want to differentiate this. That's what it's saying. Show by differentiation that this is this. So let's differentiate this first. Well, essentially we've got a u-v function. So our u, in this case, is this part. So u is equal to x to the power of k on k squared. V is equal to k log e x take 1. Okay, so u dash, considering that k is just, a constant, we actually get k multiplied by x to the power of k take 1 over k squared. Now obviously one of these k's is going to cancel, so u dash is just going to be equal to x to the power of k take 1 over k. And v dash is just going to be equal to k on x, and that negative 1 will go. So what we've got is d by dx of xk over k squared times k log e x take 1 is equal to, now we're doing u dash v plus v dash u. It's a product rule. So u dash v, well, this is going to be x times k to the power of k take 1, k multiplied by k log e x take 1 plus v dash u, which is just going to be k on x multiplied by x to the power of k over k squared. Now this, if we expand over here, what we actually get is x to the k take 1 log e to the x take x to the k take 1 over k. Then if we expand these two out, what we're actually going to get, shockingly, because of this x interacting with this x, we're going to get x to the power of k take 1 on the top, and on the bottom we're actually going to get k. So we've got plus and minus the same thing here. So we get a much nicer situation now, because all we need to do is integrate both sides. Okay? So if I integrate here, all I'm going to get is x to the power of k on k squared multiplied by k log e to the x take 1. Then if I integrate here, well, this is what I'm looking for. So the truth is, these things have now gone. And so what this is telling me is that the integral of this side here must be equal to this over here, obviously, with respect to x. So there you go. That's my answer. Now, this next question, believe it or not, being a part B, it's going to try and lead on from part A. Now, this might have felt fairly unconnected so far, but this function here is going to come into play with this. So my probability that x is greater than 1 on e is actually the integral between 1 on e and 1 of my function x. Now my function x, in this case, is obviously this thing that I've just pointed at, this negative 4x log e to the x. So bearing that in mind, I don't know how to differentiate, how to integrate this. But that's why they did this previous part of the question. They've actually told me how to do this, because they've said the antiderivative of something like this, where k is a positive real number, is this, essentially. This whole answer that we got here. So what we actually need to do is create a k for our situation. Now the first thing that I'm going to do is take this -4 out, because I'm not too bothered about that. Won't lie, OneNote keeps crashing. But basically this is this. And what I've got to do is identify the fact that this is the same as this. So I need to say, okay, well, if my k was 2 in this above situation, what I'd actually have is this. I'd actually have 1 on e to the 1, and I'd have x to the power of 2 take 1 log e to the x. So this allows me to use this left-hand side of the equation to pop my answer straight out. So I've got -4 times by x to the power of k, so x to the power of 2, over k to the power of 2, so 2 to the power of 2, times by 2, because that's k, log e to the x, take 1. Alright, and this is between 1 and 1 on e. So this has made that integration much, much easier. And if I now, I'm just going to move this to the left a bit to give myself some space. But basically, I can now just substitute in the 1 and the 1 on e. So I've got -4, which I'm going to keep on the outside. I'm going to substitute in that 1 squared on 4. So technically just a quarter. Let's not overcomplicate it where we don't need to. Times by 2 log e of 1, take 1. This is going to take away 1 on e squared over 4 times by 2 log e to the 1 on e, take 1. Alright, so this whole thing's getting multiplied by 4, at -4 at the end. So I'm just going to keep that on the outside there for now. Now this, log e to the 1, is just 0. So the first thing that I've got here is a quarter times by 0, take away 1. And then the next thing I've got is 1 on e squared on 4, which is just going to be 1 on 4e squared. And then I've got 2 lots of log e 1 on e. Well, that's just -1 if we think about it. Do a bit of maths at the side if you need to. Take 1. So what we've actually got going on here is -4 times by, this is just going to make -1/4, take away, then this is just going to come out to be -3. So what we've actually got is a +3 on 4e squared. Now this is hopefully going to come out a little bit nicer. These two times in each other is just going to make a -1, +1, sorry. And then this is going to make a -4 times by 3 on 4e squared. So these 4s are going to cancel. And so we get our final answer is 1, take 3 on e squared. Now the final part of the question is pretty messy. You're given that e is greater than 5 on 2. Well, you know that the probability x is greater than 1 on e, okay, is actually equal to what we just got there. So 1 take 3 on e squared. So given that e is greater than 5 on 2, we can actually say, well, that means that e squared is greater than 25 on 4. Now if we do the reciprocal of this, we can say that 1 on e squared, and we have to flip this sign as less than this, and we can therefore say that 3 on e squared is less than 12 on 25. Now 12 on 25 itself is less than a half, which means we've got 1 take away something that is less than a half, which means actually this is greater than a half. So we know that p of x greater than 1 on e is greater than a half. The median must be greater than 1 on e. Now, a good way to think about this is if you think about that little curve that we had at the start, the probability that x is greater than 1 on e is more than a half, which means there's more than a half of the data left. So our median, if you remember, this is greater than a half in this section. So our median must be exactly where there's only a half of the data left, which means that the median must be greater than 1 on e.